Um, so I think the format for this presentation, no PPT, we'll just focus on, I want to build a framework for you guys to think about building trust in software. And provoke some thinking in you folks. Many of you are developers here, and think about some behaviors as you write code, these kinds of things. How many of you here are developers? Just a show of hands. Okay, fantastic. How many of you think that today there's a trust deficit in the country? Every day there's some new committee forming and saying we'll solve that problem, this kind of thing. Can I see a show of hands again? Okay. I'm not here to talk about that I can guarantee, but about how you can do it in software. So it's a very specific, easier space. The one thing to remember with trust is it takes a very long time to build. Whether it's a company you work for, whether it's a software that you have. You saw the previous two presenters talk about security. You also talk about the trust in terms of, when you promise a certain experience, then it should be delivered. So these are common themes across all companies. So the key thing to remember is, it takes a long time to build trust in many of your, let's say even an online banking application, but overnight you can spoil that. And all customer-obsessed businesses, you have to be very careful about, what trust means. And the hardest thing to do is to actually answer a customer service call saying, this is why we lost your data, or this is why your privacy was compromised, or this is why the website is not available, essentially. So, so really there are three pillars. There's security, there's availability, and privacy of trust. Now, I'm not going to go into protocol details of all this, given the limited time that we have, but more about how to think about this as you architect and design and write your software, essentially. So I saw many show of hands for developers out here. How many of you, and be truthful on this one, right? How many of you actually keep your specifications updated with respect to what the software is doing? Show of hands, please. I see some smiles already. Fantastic. This is exactly what I expected. So it's interesting, right? We build a lot of software. And then we design stuff. So the design actually says something that we actually don't end up building. There's usually a gap, essentially. And it's very interesting that in security, right, the kinds of problems that people actually, the vulnerabilities that show up in the software is actually in that space where, you said that you do a design and a specification, but you actually build something. The design minus the what you build is actually where the gaps lie, where most of the security problems and vulnerabilities are. So make sure, you keep your specs up to date. I know it's one of the hardest things to do. Software engineers are like that, right? I mean, I know if you guys talk to your boss and say, I'll be on time tomorrow at 10 o'clock for this meeting. How many of you are actually on time when you come into work? Wow, that's pretty good. But I see it's about maybe 30%, I think, still. So that's like just how developers work, right? There's other departments in companies that are very much on time, all these things. But again, it goes to show that you have your own culture. Developers have their own culture. But make sure that when you write specifications and design to it, make sure that it's close. The other thing to remember is it's a very high bar for you guys to keep up to. Attackers sometimes have to be lucky just one time, right, to get in. But you guys, developers, need not. You don't have to do that, right? You have to be right all the time, actually, because the moment there's a gap, the luck factor for the other guy works out. So keep that in mind. The odds are against you, actually. So that's really about security. And so just a question, right? I'll just again show of hands here. Many of these websites that you go to today, or even applications that you use, have vulnerabilities. I'm just going to list a few here, video game sites, celebrity sites, song lyrics, social networking, and pornography. How many of you think social networking is the #1 place where you actually lose credentials and get hacked, essentially? Customers get hacked. Okay? How many of you think it's song lyric sites? How about video games? Pornography? Okay? It's interesting. Turns out the ranking is video games first. There's clever ways of getting hacked when your customers go to a video game site. Pornography is next. Celebrity, song lyrics, and then the last is social networking. I mean, they're all high on that stack over there. So it's these are the kinds of things that we face today. Now I'll move into another area about availability. That's another pillar of trust. And availability is things like, I work at Amazon where we make sure that our website is up and running so that customers can purchase things, these kinds of things. So we talk about things like availability, right? We talk in terms of percentage, 99.99999, whatever, 5 nines, all these things. So you guys might have heard all these things. And typically the speak is redundancy, availability. When you build your databases, what kind of connections are you going to scale to, this kind of thing. Sure, that's all great, fine and dandy. But really, those are engineering-centric questions which you'll do anyway in terms of availability. But the questions to ask are things like, make it availability-centric. Why do you use C++? Why don't you use Java? Or why do you use Java and why not C++? So make sure you answer these trade-offs. Do you know about memory, buffer overruns that you can do in C++? Do you know if Java has the same problems? These are the kinds of things you guys should be thinking about. Just step back a little bit. Think of the big picture. Because the details in terms of, okay, how many connections can my backend server scale to, these kind of things, redundancy, multi-site data center stuff, these are all things anyway you're going to do as part of the parcel, right? Failure. Expect failure to happen. How many of you think that most failures in data centers are due to hardware problems? Okay. How many of you think it's due to human error? Okay. How many of you think there may be a third category where it's neither hardware nor human error? Okay. So it turns out last year among data centers in the world, there were about 10 incidents where there were mammals, other mammals than humans causing problems, such as rats and rodents. Okay. Now, here's what happened, right? Technically what happened is the rodents got into the data center. They went and jammed up. Some of them died. And the sprinklers came on. There was a fire. It wiped out the hard disk. CPU was showing high, so everyone thought, the monitoring systems say that my data center is running fine. But it turns out the data was wiped out. So it's actually, your monitoring systems are lying to you, right? So expect failure. That is the name of the game here, right? Expect failure. And I'll just give you an example of a parallel in the aircraft industry as to what availability actually means. So there was a time when Boeing 747s were not there, jets were not there, and Cessnas, which are like smaller planes, was supposed to have an availability of 99.98%, which means in a year they can only be on the ground for 52 minutes for the entire year, including refueling, including landings, takeoff, any maintenance, all of these things. Can you just imagine what that means, right? Half the time, or I shouldn't say half the time, 99.98% of the time, they're in the air. So how do you actually build more reliability into that? How do you first satisfy that whole requirement, right? Make sure you think of your systems as being much simpler, right? When you build big systems, make sure that they're simple, because as you keep adding more components, racks and things like that, and more software, it should be plug and play, right? Don't make it too complex. There is sometimes an understanding that large-scale systems are very complex. That's just the wrong way to think about it. Make them simple so that you can plug and play, because it'll be easier to add more, hardware, things like that, and more capacity. The other thing with keeping systems simpler is dependencies, right? You don't run into these graphs of dependencies where you have to manage, if I install this thing here, then I need to bring in this, and that downstream component has to scale up, these kinds of things. So make sure you do that. Also think about your software as components, like appliances, essentially, right? One example is, how many of you are familiar with what a laundromat is in some parts of the world? These are basically places where you have hundreds of washing machines sitting in one place where people come and share, and then they put in coins and operate the washing machine, right? Funnily, a lot of the lessons in distributed systems design have come from laundromats. How many laundromats? There are about 35,000 laundromats in the US. And these are centers, right? 35,000 as in 35,000 into 100 of them, right? So many numbers. But it turns out that the availability of laundromats is very, very high. Customers actually don't, run into problems over there. So think of them as appliances, right? There's an electricity thing, there's a water thing coming in. Think of them from a big picture standpoint. Also verify your, what you do. Trust. your engineers and your peers and all that, but also verify. Trust but verify. That's super critical. And the last thing I'll talk about, the last pillar of trust, building trust into software, is privacy, right? So there was a study done last year, and for customers, companies that maintain customer data, whether it's a bank, whether it's a social networking site, e-commerce company, a payments company, there was a cost attached to each record, customer record, in terms of a privacy loss. And I talk in rupee terms. How many of you think it's about, say 5,000 rupees? Show of hands, please. The cost per record, so it has not been compromised. It is sitting somewhere in some database. What could the cost be from a privacy standpoint if that data was lost? How many think it's 5,000 rupees? How many think it's more? Okay, you're on the right track. Turns out it's about $180 or about 10,000 rupees. That's the cost of, if you had a breach, how much money would it cost to do a public policy change? There are legal consequences. You have to pay fines in the US, for example, about when you lose data like that. So privacy is a big issue. Also be careful about what kind of things, when you build your software, give a notice to the user as to what you're doing with the information you're collecting, right? There has to be consent and choice. The user chooses, I want to do this, I want to do that, or I don't want to do this. Make sure it's very explicit. Onward transfer, so I will do this with the data that I collect. And many of you must have signed loan forms, or when you sign up for a new mobile service. Let's see another show of hands. How many of you actually read the fine print behind the customer policy in terms of privacy? Show of hands, please. Wow, so some people are very diligent, right? But that's about, I think, 0.1% of show of hands, right? So there's a privacy policy in all of these. So make sure that you also surface that. So I'll give you I'll just give you a couple more examples, right? There was a company last year called Choice Point that had customer credit card data, and it turns out it was leaked to the criminals actually. And when that company was contacted by the authorities in the US, they said they will only disclose that this has happened to customers in California, because that's what the law says. Do you see a problem there? The company is not being truthful, right? In terms of, it's a policy, legal adherence, but it turned out that the day they did that, the stock dropped, and I think it took a tanking of about 1/10 essentially. It became 1/10 of what it was. Trust in that company was lost, right? It turned out that the person who was actually having their, and it was supposed to be a high secure company and all this, the administrator was keeping the passwords and credit cards in clear text on the network. It's the administrator, right? We're talking about something where a policy has to be enforced. So make sure you think of all these. And as you do your processes, right, how do you actually get into the development cycle? You might do waterfall. How many of you do waterfall? How many of you do agile? Okay, looks like more agile. So every time during a sprint planning sessions, whatever it is, right, make sure when your stand-up meeting happens, there has to be a czar or a champion of privacy each time. Make sure you ask those questions. If the ownership is on you as developers to ask all these questions. Could there be a privacy breach? Could there be a trust breach at the end of the day? So really, so I'm almost out of time here, but if there's one thing, I'd like you to take out of this talk is really about trust, right? It's basically, trust takes a lot of time to build. You can work hard, build all the most fancy algorithms and all of these things, fastest processing, best UIs, all of these things. But it can be lost overnight. And imagine yourself in that situation as a customer, right? All customer-obsessed businesses have to build trust into their software. Thank you very much for your time.